Welcome to Grab and Go Info. Gradient descent is a commonly asked concept in data science and machine learning interviews. Some example interview questions are: what is gradient descent? What are the pros and cons of stochastic gradient descent? What are the differences between batch gradient descent and mini-batch gradient descent? In this tutorial, we will answer these questions by comparing gradient descent, stochastic gradient descent, batch gradient descent, and mini-batch gradient descent. Let's get started. Gradient descent is an optimization algorithm used to find the minimum of a function. It works by iteratively moving in the direction that reduces the value of the function the most. Gradient descent is a common algorithm used in machine learning to find the optimal parameters for a model. It can be used for both linear and classification models. There are three commonly used gradient descent types: batch gradient descent, stochastic gradient descent, and mini-batch gradient descent. The main difference between the three variants is the amount of data used each time the weights are updated. Batch gradient descent uses the entire dataset to compute the gradient for each parameter update. The pros of batch gradient descent include: 1. Stableness. Batch gradient descent is stable in gradient and convergence because it uses the entire dataset to compute the gradient at each step. This can make it more likely to find the global minimum of a function. 2. Computation cost. Batch gradient descent is computationally efficient, as it uses the entire training dataset to compute the gradient of the cost function at each iteration, and the parameters are only updated once after each epoch. The cons of batch gradient descent include: 1. Training speed. Batch gradient descent can be slow to converge when the training dataset is very large, as it uses the entire dataset to compute the gradient at each iteration. This can make training time-consuming and impractical in some cases. 2. Memory requirement. Batch gradient descent requires high memory for large datasets because it processes all the samples in the training dataset at the same time. 3. Suboptimal solution. Batch gradient descent tends to converge to a suboptimal solution. This is because the gradients are stable and it's hard to jump out of a local minimum. Stochastic gradient descent updates the model weights using one record at a time. The pros of stochastic gradient descent include: 1. Less memory needed. SGD requires less memory as it uses a single training sample to compute the gradient of the cost function at each iteration. 2. Escape suboptimal solution. Stochastic gradient descent provides opportunities to discover new and potentially better weights. This helps to escape the local minima or saddle points. 3. Online learning. SGD is well suited for online learning, where the model is trained incrementally on streaming data. This makes it a good choice for applications that require real-time prediction or model updates. The cons of stochastic gradient descent include: 1. Stableness. Stochastic gradient descent is not stable. The frequent updates of the weights can produce noisy gradients, causing the loss to fluctuate instead of slowly decreasing. 2. Convergence. Stochastic gradient descent tends to have higher variance and may diverge instead of converging to the global minimum. 3. Computation cost. Stochastic gradient descent is computationally expensive because the parameters are updated for each sample. Mini-batch gradient descent lies between batch gradient descent and stochastic gradient descent, and it uses a subset of the training dataset to compute the gradient at each step. Mini-batch gradient descent combines the benefits of batch gradient descent and stochastic gradient descent. The pros of mini-batch gradient descent include: 1. Computation cost. Mini-batch gradient descent is more computationally efficient than stochastic gradient descent because it updates the parameters after a batch of samples. 2. Stableness. Mini-batch gradient descent is more stable than stochastic gradient descent because it utilizes the information from more data. 3. Less memory needed. Mini-batch gradient descent requires less memory than batch gradient descent because it uses a small subset of training samples to compute the gradient of the cost function at each iteration. The cons of mini-batch gradient descent include: 1. Mini-batch size. Mini-batch gradient descent can be affected by the choice of mini-batch size, as a mini-batch size that is too small can decrease the convergence rate, while a mini-batch size that is too large can make the algorithm behave similarly to batch gradient descent. Batch size is an important hyperparameter to tune in mini-batch gradient descent. Overall speaking, each gradient descent type has some advantages and some limitations that can make it less effective in certain situations. In general, mini-batch gradient descent is preferred, but it may be appropriate to use other optimization algorithms, such as stochastic gradient descent or batch gradient descent in certain situations. If you have made it this far, you probably find the information in this tutorial helpful. Please click the like button and subscribe to the channel to get notified when I publish new videos like this. To learn more about data science interview, please click the YouTube playlist on the screen now. Thank you for watching and see you in the next video.